Hi, so let's start this question. A random sample is selected from a normal population with mean equal to 100 and a standard deviation equal to 20. After a treatment is administered to the individuals in the sample mean is found to be 96. And the first question they're asking, how large a sample is necessary for this sample mean to be statistically significant? So statistically significant means to reject H naught. So as we know, to reject H naught, we need to find the critical value. And when the calculated test statistic falls in the rejection region, we can reject the null hypothesis. So, and they are talking about two-tailed test with alpha equal to 0.05. So we first uh, try to find the critical rejection region or the critical value. So it's two-tailed and alpha is equal to 0.05. Since it's two-tailed, we need rejection regions on both sides. So we'll have rejection regions on both sides, and the probability of this region altogether is equal to this alpha. So each side you will have the probability alpha divided by 2. So it's alpha divided by 2, that means 0.025. So we need to find this value, this critical value, or the value, the boundary where the rejection region starts. So for that, you know the probability of this area. You can go check the tables and then find the value here. So since I know the probability in the tail, which is 0.025, let's go back to the table and see. So here C column shows the tail, and I'm going to find the value Z or Z. I know the probability of this area, which is 0.025. So I'm going to scan through this column C, until I find something similar to or something approximately equal to 0.025 in column C. So you can see here this is column C and it goes 0.02. Okay, here you have 0.025 exactly 0.025, and the Z value is 1.96. So that's our critical value. And this alpha equal to 0.05 is the common case. So when you do more examples, you will even remember this value, the critical value. When alpha is equal to 0.05, and if it's two-tailed test, then the critical value is 1.96. So we found the critical value, and here they're asking how large a sample is necessary. That means the maximum sample size for the test statistic to fall in the rejection region. So here you can see there is a limit. That means they are asking the maximum sample size. That means even if my test statistic is here, that means we are going to reject the null hypothesis. So this is the starting point. Same here on the other side. So we are going to consider this critical value when calculating the sample size. Let's write the test statistic equation. That is Z, which is equal to m minus mu divided by sigma m according to the textbook. So this test statistic should be like to find the maximum sample size. If this test statistic is exactly on the boundary, still we are going to reject the null hypothesis. So let's make it equal to 1.96. And m was given, m is 96, mu is 100. So this is 96, mu is 100. And we don't know the value of this sigma m because sigma m consists of, that includes the sample size. So let's find, I'm going to cross multiply. I'm going to take this to this side and take this here. So my sigma m is equal to 96 minus 100 is negative 4 divided by 1.96. since sigma has to be a positive value, I can consider negative because you have negative or positive 1.96. So I can consider the negative 1.96. So this will be positive. So I need 4 divided by 1.96, which is equal to 2.0408 sigma m. I'm going to use only 2 decimal places, so I'll write this as 2.04. Right? Now, I know the equation for sigma m. Sigma m is equal to sigma divided by square root of n. And I'm going to find the value of n here. So I know the value of sigma m now, so I can substitute. So 2.04 is equal to, so sigma value is given. Sigma is equal to 20 divided by square root of n. So again, I'm gonna cross multiply, take this square root of n here and take this 2.04 down. So square root of n is equal to 20 divided by 2.04. 20 divided by 2.04 is 9.80. 9.8039. So I'll keep as 9.8039. Okay, I'll make it 3 decimal places, 804. Then I need to find the value of n, not the square root of n. So if you have the square root of n equal to 9.804, you can get the squared value of both sides. So I'm gonna square this. So squared value of square root of n becomes n, and 9.804 squared is equal to 96.11. In this type of questions, even though these decimal places are small, so we are asking about the maximum sample size. It's a sample size, so you have to round it to the next decimal value. So n is equal to 97. Because you need n, the sample size, which is equal to 96 point something. So you need a sample size little bit greater than 96. Since it's a discrete value, so you have to use a whole number. So n is going to be 97 in this case. So that's the final answer. So it's easy. The only thing is you have to equal the critical value and the test statistics. So for that, you need to find the critical value first. So that's all for this question. And the final answer is 97.